On your screen in front of you, you see the phosphorus cycle itself. Now there's arrows moving in many different directions, which means that the cycle itself is rather complex. It's not as complex as, say, the nitrogen cycle, but it is more complex than, say, micronutrient cycling within soils. Okay, so there's various components, much like the nitrogen cycle, that move between phases within the soil that can be lost due to plant uptake or leaching or runoff or etc. Then there's inputs. So let's talk about this cycle in general, and then we'll get into the cycle in more detail. So first, let's talk about the inputs. The inputs of phosphorus to a soil are through materials like fertilizers. We as humans can apply phosphorus fertilizers to soils. Phosphorus can also be input into soils via animal manures, biosolids, other organic amendments that contain phosphorus itself. Phosphorus can be returned to soils via plant residues. If you leave standing mulch on the ground following corn or wheat harvest, soybean harvest, you leave the material back or you leave it set on the ground, that'll return phosphorus among other nutrients back to the soil. Atmospheric deposition can occur. It's probably not as great as some of these other phases for returning phosphorus to a system. Now let's talk about losses. One of the loss pathways for phosphorus from a soil is plant uptake and crop harvest. And I can tell you that this phosphorus removal mechanism isn't really all that great. It does remove some phosphorus. It's not that great. There is some leaching. Leaching can occur. Oftentimes this is minor, but it could be major depending on how management has affected the soil system itself. We'll talk about this. And by and large, phosphorus moves from soil systems to a great extent, relatively speaking, compared to the other loss pathways via runoff and erosion. I would say 90, maybe even 95% of phosphorus is bound to soil particles. And when sediment or soil particles are moved off site, there goes phosphorus. So we'll talk about those. We'll talk about some inputs, we'll talk about losses, and we're going to talk about the transformations within the soil itself. Okay, so let's take a look at the transformations in the soil on this phosphorus cycle. Here is the pool by which plants obtain phosphorus, soluble phosphorus, as H2PO4 with a minus charge, or HPO4 with a -2 charge. These forms are often referred to as orthophosphate or soluble P. The terms are interchangeable. These forms enter the soil solution via a couple of different pathways. The pathways with arrows leading to this pool from the right are basically, this is diffusion for the most part over here, right? This is mostly diffusion. The other pathway by which phosphorus or ortho-P or soluble P enters the pool is from the degradation of organic materials that contain phosphorus, i.e., this is through mineralization. The term mineralization here is the same term that you learned in the nitrogen unit, and the nitrogen cycle specifically. Mineralization of organic phosphorus to inorganic phosphorus occurs, and the flow path is to the soluble P pool. Of course, immobilization can occur as well, where if microorganisms are perceiving a deficiency, they'll scavenge the orthophosphate pool to take up phosphorus into their tissue. Regardless, it's important for me to tell you that when phosphorus is mineralized and it ends up in this pool, soluble phosphorus hates being by itself. I can tell you that phosphorus in soils love to be loved. And where does soluble phosphorus end up after it's mineralized? It ends up going to the right, oftentimes, and forming associations with iron, aluminum, calcium, manganese, um, and it's pulled out of the soil solution phase so the plant can't see it. So what we're going to do next is we are going to focus some attention first on this portion of the P cycle. Why are we going to focus on these three phases? The soluble phase, the mineral phase, and the secondary phase. The reason is these primary minerals, there's no reason for us to really talk about these. These are primary phosphorus-containing minerals in the form of apatites that are present initially in soils. These forms dissolve via weathering. Pump soluble P into the solution phase. Phosphorus loves to be loved. And what phosphorus typically ends up doing in these types of soils that contain apatite, which have a high pH, right? The pH is above 8. Phosphorus loves to be loved, and it ends up typically forming secondary mineral compounds that are calcium phosphates, which are apatites. And these minerals are the ones in our soils, if they're present, not just calcium phosphates, but iron, manganese, and aluminum phosphates. These secondary mineral compounds that contain phosphorus are the compounds, in addition to mineral surfaces, that feed phosphorus into the soluble phase that plants can see. And this occurs via diffusion. So this is what we're going to focus on next, this box right here.